let's talk about a ninth century Persian mathematician whose ideas are, and this is no exaggeration, woven into the very fabric of our modern world.
Yeah, that's right. Every single time you solve for x, you're basically speaking his language. He's the one who wrote the grammar, so to speak.
And get this, his ideas are from over 1,200 years ago, but they're the engine powering every single computer on Earth today. It's wild.
So today, we're diving into the story of Muhammad Al-Khwarizmi, the man who literally turned numbers into knowledge.
Okay, so to really get Al-Khwarizmi, you have to understand the world he lived in. I mean, this guy didn't just pop up out of nowhere. He was part of something huge.
So take a look at this timeline. We're talking about the early 9th century. This places him smack in the middle of the Islamic Golden Age. He wasn't some lone genius in a dusty room. He was part of this incredible, state-sponsored mission to collect and build upon all of human knowledge.
Right, and the epicenter of all this was the House of Wisdom in Baghdad. Al-Khwarizmi was one of its leading scholars. You gotta picture this place. It was like NASA, the world's best university, and the Library of Congress all rolled into one. Scholars from everywhere came here to translate, debate, and push the boundaries of science. It was an absolute intellectual supernova.
And it's in this, supercharged environment that he writes the book that changes everything. And in the process, he gives us a word that pretty much every student knows and maybe fears a little: algebra.
So the book's title was, a bit of a mouthful, The Compendious Book on Calculation by Completion and Balancing. The first key idea was al-jabr, which literally means restoration. It's that move you do, when you take a negative number from one side of an equation and flip it to the other to make it positive. You're restoring it. Sound familiar? Yep, that's exactly where we get the word algebra. Okay, so that's part one. The second part was al-muqabala, which means balancing. This is the other thing you always do in algebra, subtracting the same amount from both sides to simplify things. So you put al-jabr and al-muqabala together, and what do you get? You get a systematic, step-by-step way to solve for an unknown. He basically invented a universal toolkit for finding answers.
But here's the real kicker, and this might blow your mind. He did all of this without X or Y. No symbols at all. He just used words. He'd literally write a thing, or a quantity, instead of X. And to prove his ideas worked, he didn't use abstract formulas. He used something anyone could understand: pictures and geometry. And this is just a beautiful example of how he made algebra visual. He wanted to show what happens when you multiply, say, a plus b by itself. So what does he do? He just draws a square with sides that are a plus b long. And by adding up the areas of the little boxes inside, he could visually prove, that the total area is a squared plus b squared plus 2ab. It's a proof you can literally see. So cool.
And this right here, this is his masterpiece. His technique for solving those tricky quadratic equations. Let's say you have x squared plus 10x equals 39. Sounds tough, right? Well, he'd just draw it. He'd start with an x by x square, add on some rectangles for the 10x, and then he'd figure out what little piece was missing to, complete the square. Suddenly, a nasty algebra problem turns into a simple geometry puzzle. It's just brilliant.
But wait, there's more. Algebra wasn't his only game-changing contribution. He was also a key player in popularizing the number system that, we all use every single day. Okay, before Al-Khwarizmi's work got around, Europe was stuck with Roman numerals. Just look at this slide for a second. Try doing that simple addition problem on the left. It's a total nightmare, right? Now look at the right. Easy. His work helped bring the Hindu-Arabic numerals, our numbers, to the wider world, and it made math accessible and, doable for everyone. And part of that new system included something truly revolutionary, an idea from Indian mathematicians, the number 0. I mean, this wasn't just a placeholder for nothing. It was a number in its own right. And that one idea, that concept of 0, is what makes the whole decimal system work. It's the foundation for all of modern math. His work was so fundamental, so important, that his actual name gave us a word that basically runs our entire digital world today. So when his book on arithmetic got translated into Latin, the first line was Dixit Algorithmi, which means Al-Khwarizmi says. People started associating his Latinized name, Algorithmi, with this new way of doing math. And over time, algorithmi just morphed into the word we all know, algorithm. And what is an algorithm, really?
It's just his way of thinking, written down. It's a simple, step-by-step process. You start with an input, you apply a clear set of rules, and you get a consistent output every single time. It's the same logic he used for everything, and it's the exact same logic that your computer uses for, well, for everything.
It's not an exaggeration to say that the echoes of Al-Khwarizmi's thinking are literally all around us, powering technology that would have looked like pure magic back in his day. Just think about it for a second. A search engine sifting through billions of websites in a fraction of a second, that's an algorithm. Your GPS finding the best route home, avoiding traffic, that's an algorithm. Financial trading, artificial intelligence, computer programming, science, engineering, every single one of these runs on that core idea. It's all a direct line back to Al-Khwarizmi.
You know, the historian Robert Briffault really nailed it. He said that the scientific spirit that makes our modern world possible, it really has its clearest roots in this mathematical explosion during the Islamic Golden Age, and Al-Khwarizmi was right at the heart of it. So in the end, he gave us a way to solve for the unknown, a logical, repeatable process for finding answers. He basically taught us a new way to think. And that leaves us with a pretty big question, right? Now that we have these incredibly powerful tools he helped create, what are the next great unknowns that we're going to solve?